Hi there, this is Math 6, Unit 7, Lesson 6, Absolute Value of Numbers. So we're going to be exploring the distances from 0 more closely today, and so that's what we're going to be talking about, which is a lot of what we're talking about when we're dealing with absolute value. Okay, so first of all, we have some number talk called closer to 0. For each pair of expressions, decide mentally which one has a value that is closer to 0, and which one is closer to a 0. Now, okay, you have to kind of think through them. For the first one, we have the same denominator here, right? And so you're thinking about closer to 0 is going to be the smallest, okay, overall. So if this was like a pie divided up into 11 slices, this one would have 9 and 11 slices, okay, and the other one would have 15 out of 11. Wow, that's even bigger than that one, right? So when you compare the 11s, when the denominator is the same, you can compare the top numbers and go, well, let's see, this is a lot larger, which makes this one closer to 0 overall, okay? For your 1/5 or 1/9, again, which one is a smaller number? Well, the greater the denominator is, the more slices you're cutting that pie up into. And so we would say this was a smaller one because it's 1 piece out of 9 compared to 1 out of 5. The next one, we have 1.25 and 5 over 4. So with some mental math here, I know that 1.25 is like 1 and 1/4, just thinking about what is the fraction. And 5 and 1/4 can be rewritten as 1 and 1/4. So in this case here, they're going to be the same distance to 0. It's the same number. And finally, the last one, I have 1/10 and I have 1/100th. This one is a much smaller number, so it's definitely going to be closer to 0. Okay? So again, just something to talk through and to think about which one is closer to 0, and just using some mental math or mental kind of arithmetic to figure out which one it would actually be. You don't really need to solve anything, we're just talking about it. Alright, so there we go, the jumping flea. So the flea is jumping around on a number line. If the flea starts at 1 and jumps 4 units to the right, okay, so we're going to go 4 this way, where does it end up? Okay, so it starts here and it's going to jump 4. We're going to go 1, 2, 3, 4. So we're going to end up right here. So where is that spot? Well, on a number line, we'd count that as 1, 2, 3, 4, 5. So it ends up on the 5th mark in this number line. So how far away from 0 is that? Well, it's going to be all the way from 0 to 5 for a total of 5 units away, whatever those units are. So it started at the 1, hopped 4 to the right, and now it's at the point 5, which makes it 5 units away from 0. If the flea starts at 1 and jumps 4 units to the left, okay, so now we're going to go this way 4, right? Where does it end up? Well, let's do that. Let's take it here. In fact, I'll use a different color. Let's go left. Let's go 1, 2, 3, 4. So it ends up right here. Over here, I'm at -1, -2, and -3. So where does it end up at? It ends up at -3. Second question, though, is how far away from 0 is that? What's the distance from here to here? Well, the distance from here to here is 3 units. Okay. If the flea starts at 0 and jumps 3 units away, where might it land? So we're going to say it starts at 3, or starts at 0 and jumps 3 units away. Where could it land? We already know if it jumps this way, it would land here. So that's one place it could land, is at -3. If it went this way 3, it would go 1, 2, oh sorry, start at 0. 1, 2, 3, and we'd have here at this point at +3. Okay, starting at that one. Sorry, that's why I don't use pens all the time, right? So, where might it land? It could land at -3 or +3. If it went from this point here from 0 and went 3 that way or 3 that way. If the flea jumps 7 units and lands at 0, where could it have started? So coming back the other way, where could it start if it jumped 7 units and landed at 0? For this one, you can think about, okay, let's go the opposite direction. Let's go 7 this way. So if we start at 0, we could go 1, 2, 3, 4, 5, 6, 7. So it could have started here and gone that way, 7. Or 1, 2, 3, 4, 5, 6, 7. It could have started here and gone that way, 7, right? Which puts it at +7 or a -7 is where it could have started at in order to move 7 units either left or right to get there. So it could be -7 or a +7. The distance is exactly the same. And that's really what we're talking about here. We're talking about the absolute value. And we're talking about absolute value, we're talking about the distance from 0, how far away it is. So for both of these, how far away is it from 0? It's 7 units away. Doesn't matter if it's negative or positive, the distance we're talking about from 0 is going to be a total of 7 units. Let's look at this in a little different context. Okay? Well, let's continue, I should say. The absolute value of a number is the distance it is from 0. And that's the key thing to remember here. The absolute value of a number is the distance it is from 0. The flea is currently to the left of 0, and the absolute value of its location is 4. Okay, so it's to the left of 0. Here's 0. And the absolute value of its location is 4. So we go 1, 2, 3, 4. Absolute value of location 4 means it's 4 units away. And because to the left, or on this side, will be at -4, is where that's located at. If the flea is to the left of 0 again, and the absolute value location is 5, where is it on the number line? Again, same idea, right? If this is 0, and we're absolute value, the distance from 0 is 5. Just read that like that. Absolute value is 5, the distance from 0 is 5. 1, 2, 3, 4, 5. That's my distance. So what's the location? Where is it? It's right here at -5. If the flea is to the right of 0, okay, so now we're going this way, here's 0, and the absolute value, the distance from its location is 2.5, so here's 1, here's 2, here's 3. Where is it? It's going to be at 2.5, which is here, but that's just simply 2.5. So in our first one, when it's to the left, we had negative numbers, but the absolute value is describing a distance, and a distance is not negative. A distance is actually positive. So, I mean, you just can't walk a negative foot. You're either going forwards or backwards, but it's not really negative, is it? We use the notation line, or like an absolute value sign, -2, absolute value, to say the absolute value of -2, which means the distance from -2, the distance from -2 from 0 on the number line. So this is absolute value, which means the absolute value of -2, which means the distance of -2 from 0 on the number line. Okay, so that's the way this is written and formatted. So what does this mean? So this is going to mean a couple things. This means for us that it is 7 units from 0, okay, and the value of it is, in terms of like what it is, the value of it is going to be 7. So the value is 7, and what it means, it's 7 units from 0. Okay. You can also say this means the absolute value of -2. Or -7. Which in terms of means, the distance from of -2, 7 units from 0. So what does this mean? Well, this means it is 1.8 units from 0, all right, and it has a value of just simply 1.8. So the positive ones are pretty straightforward, right? The negative ones, the value is going to be positive. And the reason it's positive is you're talking about the distance from 0. A part of the city of New Orleans is 6 feet below sea level. We can use -6 feet to describe its elevation, and absolute value of -6 to describe its vertical distance from sea level in the context of elevation. In the context of elevation, what would each of the following numbers describe? So what we're saying is, if sea level is here at 0, right, and there's a city down here at -6, that's its elevation. But in terms of describing its distance, the absolute value, oops, leave space here, the absolute value of -6 is equal to 6, because that is the distance from -6 to 0. Okay? So looking at these, 25 feet. if it's 25 feet, that tells us that it's going to be what? 25 feet above sea level. So 25 feet above sea level is what it tells me there. Okay? And it's a distance of 25 feet away from sea level. This one, though, tells me the distance between a point 25 feet above sea level and the sea. Okay? So if I talk about the absolute value of 25, now I'm talking about the distance between some point and sea level. That's the difference. 25 feet is just a point right there. Absolute value 25 point, we're describing the distance between the point and 0. That's the idea. Absolute value is describing the distance between the point and 0. Okay, got me there? So -8, what is -8? That's just going to be a point, okay, that is going to be 8 feet below sea level. That is just a point there. It's 8 feet below sea level there. But this one, the absolute value, whoops, yeah, got it. The absolute value of this one, it means what? The distance between a point 8 feet below sea level and sea level. That's going to be that distance, right? So this here, absolute value of 8 feet, is talking about the distance from here to here, just like the absolute value of 25 feet was talking about the distance from here to here. Okay? Now, again, the points, -8, was just the location, where that's going to be. 25 was just the location. Okay? The absolute value is describing the distance between those points. So the next question says this: the elevation of a city is different from sea level by 10 feet. So the elevation of a city is different by 10 feet. Name the 2 elevations a city could have. Okay, so again, thinking about our city, or our sea level, if this is your vertical number line like so, and this is sea level at 0, it's a different distance from the sea level by 10 feet. It could be up here at +10, and it could be down here at -10 feet. Those are the 2 options that it could be. Okay, both of those have a distance in terms of elevation of 10. That's the change there. Looking at temperature, we write -5 degrees Celsius to describe a temperature that is 5 degrees below freezing, and 5 degrees Celsius for temperatures 5 degrees above freezing. In this context, what do each of the numbers describe? So if we're thinking about a thermometer and temperature, okay, and this is 0, this is freezing, where things are at, we would describe -5 as 5 degrees below freezing level, and +5 is 5 degrees above the freezing level. So what is 1 degree Celsius? That's going to be 1 degree above freezing, right? So there it is, 1 degree above freezing. -4 is going to be what? 4 degrees below freezing. It's just what the temperature is going to be. Now when we get to the absolute value ones, now we have a 12. Absolute value of 12. So notice it's the absolute value of 12 degrees Celsius. Okay? So this is going to be the distance between freezing and 12 degrees Celsius. So here's 12 degrees Celsius, and so what are we saying is the distance from here to here, that distance there is the absolute value of 12. Just like in the next one here, -7, or absolute value -7, is the distance between freezing and -7 degrees Celsius. So -7 degrees Celsius can be here, and what we're saying is that the distance from freezing to this point is the absolute value of -7. Alright, 4. Which temperature is colder, -6 degrees Celsius or 3 degrees Celsius? Well, on a scale, we could put -6 right here, we could put 3 right there, and colder, the lower down I go, the colder it's going to be, so we would simply say -6 degrees. Which temperature is closer? So here we're talking about what? We're talking about the distance to freezing. -6 degrees or 3 degrees Celsius. Which one's closer? So you're looking at that space from 3 to 0, compared to that one, compared to -6 to 0. I'll put it over here. So which one's closer? Which one has a shorter distance? We would say definitely the 3 degrees Celsius is closer to the freezing temperature. It's warmer, but it's closer to freezing than that one is, which sounds silly, but it's talking about the freezing point. Technically, once it's here, it's already frozen. So, or, you know, this is the freezing point. So keep that in mind. This is the freezing point, where it starts to freeze. Which temperature has a smaller absolute value? Okay, smaller absolute value means a smaller distance, right? Smaller distance means closer to 0. And the one that's closer to 0 in this case is still going to be 3 degrees Celsius. All right, let's turn the page. We'll look at our summary for today. Summary says, when we compare numbers by comparing their positions on the number line, the one farther to the right is greater, the one farther to the left is less. So farther right is greater, left is less. Sometimes we wish to compare which one is closer or farther from 0. So we're looking at closer or farther to 0. We want to know how far away the temperature is from freezing point, regardless of whether it's above or below. So that's our big thing. The absolute value of a number tells us its distance from 0. Okay, that's a key point there. Another key point here is that the distance from 0 to itself is 0. So the absolute value of 0 is 0 because it's can't get any further away from itself than it already is. All right, so we're going to pause there, let you work on your homework. We'll come back and check those together in just a minute. All right, homework for Math 6, Unit 7, Lesson 6, Absolute Value of Numbers. On the number line, plot and label all the numbers with an absolute value of 3 over 2. So the absolute value of 3 over 2. So we're talking about a distance away, a distance from 0 of 3 over 2. Now 3 over 2 is also 1.5. So what would that mean for us? Well, it means that I have 1 over here at positive 1.5, and I have 1 over here at negative 1.5, or negative 3 over 2. Those become the 2 points that are both the absolute value of 3 over 2, and that shows that distance there. Number 2, the temperature at dawn is 6 degrees Celsius away from 0. Select all the temperatures that are possible. Okay, so what we're saying is we have a temperature gauge here. Here is 0, okay, and 6 degrees away. Now away is talking about what again? A distance. So 1, 2, 3, 4, 5, 6. That could work, but so could 1, 2, 3, 4, 5, 6. That could also work. Both have a distance away of 6. So that gives us 2 temperatures that could actually be 6 degrees away from 0. -6 and +6. Number 3, put these numbers in order from least to greatest. Okay, so we have a 0, keep it there. These ones we keep the same. Now the absolute value, the distance from this point, -2.7 to 0, ends up being 2.7. The distance of -1 to 0, it ends up being 1. So in terms of least to greatest, we start at 0, we go to 1, then we go to 1.3, we go to 2, and then we go to 2.7. Those are the distances from least to greatest from 0. Number 4, a little review question here. Elena donates some money to charity whenever she earns money as a babysitter. The table shows how much money, D, she donates, this is our donate money, for the different amounts of money, M, that she earns. Okay, she earns $37, she donates that amount. $15, she donates that amount. So we can see she's donating less than she makes. So it is going to be some sort of percentage of the whole thing. Okay, so it's some percentage. Question A says, what percent of her income does Elena donate to charity, and explain or show your work? So percentage, when we think about percent, that is going to be how much of the part out of the whole. Okay, and we can think of different things here. We could think about that she is out of, let's use this one for right now. We can think that she's donating $1.80 out of $15 that she has. So if we do the division on that, 15 goes into 1.80, put a decimal point there, 15 goes into 18 one time, we subtract, and 8 minus 5 is 3, bring down the 0, 15 goes into 30 two times, so we have 0.2 as a number. Now that's not a percent. To turn that into percent, we have to move the decimal place twice, which is by multiplying by 100. So that's going to give us 12%. So, and that would be the same for each of these. If you divided 3.6 divided by 30, you'd get 0.12. They all work the same. You can try it with a calculator to verify, but that becomes your percentage. It's the part that she's donating divided by the money she makes. That's how we got there. So which quantity, the money or the donation, would be a better choice for the dependent variable in an equation? Now, dependent variable, remember, that means that whatever you come up with depends on the given value. So it requires information in order to come up with something, right? You put it in the machine and out comes this other thing. So when we talked before, we had our y was our dependent, and that equaled our x, which was our independent typically. Okay? That's what we did before. So which was depending? Okay, well, how much money she donates depends on how much money she makes. So we would say donation would be the dependent one, because however much she's donating is only dependent upon how much she actually makes. Now the next question on the next page does say to write an equation. So in this case here, because the donation is the dependent part, we'll make that the y. And to figure out how much she makes, okay, to figure out how much she would donate, we take the amount of money she makes and we multiply that by the percent that she donates, 0.12. So 0.12 m equals d. And that becomes our equation on the next page as well, which you could write there if you chose to. I just wrote it on this page instead. Number 5. How many times larger is the first number than the pair in the second? Okay. So 3/4 compared to 3 to the 4th power compared to 3 to the 3rd. This is 3, 2, 3, 4 threes compared to 1, 2, 3 threes. So we have 1, 2, 3, 1, 2, 3. How many times larger is it? It is 3 times larger. How about this one? We have 5 to the 3rd, so it's 5, 5, 5 compared to 5 squared. So 1, 2, 1, 2, this is 5 times larger. All right, 7 to the 10th, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, compared to 7 to the 8th. 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 over here. So 1, 2, 3, 4, 5, 6, 7, 8. 8 over here. 1, 2, 3, 4, 5, 6, 7, 8. So how many times larger is it? Well, it's 7 times 7 larger, not just 7. 7 times 7 is 49. Or you can think about it, it's going to be 7 squared. Is there a faster way to get to 7 squared looking at these? Sure. It's 7 to the 10th compared to 7 to the 8th. So we subtract these and we have 10 minus 8 is 2. So it's 7 squared is how many times larger? We figure out 49. Let's try that for the next one. So here is 17, because I don't want to write 17 a billion times. So I have 17 to the 6th compared to 17 to the 4th. So let's subtract that. 6 minus 4 is 2, so there's 2 more over here. 17 squared is how much more larger it is. So what is 17 squared? I have to use a little calculator to figure that one out there. And 17 squared is 289. Not one that I know off the top of my head. And finally, 5 to the 10th compared to 5 to the 4th. How many times larger is the left one or the right one? Well, 10 minus 4 is 6. So we're going to do 5 to the 6th power And 5 to the 6th power is going to be, in our case here, oh, I did something funny there. 5 to the 6th power. Huh. Yeah. I don't have my calculator with me. I don't know. Oh, here we go. I can do it. Let's do it real quick. I just skipped that one on my notes for some reason. Okay, so let's go with 5, 2, 3, 4, 5. All right, I got, oh, times one more, 6. So I got 15,625. I don't know if that's right or not. 5 times 5 times 5 times 5 times 5 times 5. It's a lot of 5s. This is 25, times 5 is 125, times 5 is 625, times 5 is something big, 3,000-ish, times another 5, 15. Yep, that sounds about right. So 15,625. Crazy number. Okay. Lynn's family needs to travel 325 miles to reach her grandmother's house. That is the whole trip right there. At 26 miles, what percentage of the trip distance have they completed? So they've gone part of the way, 26 out of how many do they have to go? 325. Okay, it's just like figuring out your grade on a math test. You get 26 right out of 325. So 26 divided by 325 is 0.08. As a percentage, move it 2 spaces there, becomes 8%. How far they traveled when they completed 72% of their trip? Well, 72% is 0.72 of is times, and the trip's distance is what? 325. So 72% of 325 equals 234 miles. At 377 miles, what percentage of the trip's distance have they covered? So this is, they've gone 377, that's how far they've gone, out of how many? What's the trip's distance? 325. So 377 divided by 325 actually equals 1.16, but as a percentage, we move it 2 to the right, we have 116%. So they went past their destination. Alright, that's it for today. Have a great day, and we'll see you next time.